Hi grade 12s, welcome to my channel. Let us keep enlightening each other, and of course the exams guys on Friday are going to give you a bit of a hiding. Are you gonna fight back, or are you gonna sit there and give the other cheek? Well, it's up to you really. Let's share this question. This question came from some trial exam prep exam from KZN. It was shared to me by a friend and a colleague. Shout out to you, Mr. Mbongeni Masonda. He essentially cracked the secrets in this question, and I'm just going to share his insights to you all, my students, because I want to give you the best that I can find, and I'm sure this may really help you guys to become even better. So all thanks to Mr. Masondo, and yes, hopefully I see more collabs with you, bro. So let's keep it going. Right. So Lilita has 3 6-sided die, right, that she wants to use to create a geometric series. So this is by randomly throwing the die. Now the one die is red, the other dice, remember when it's a singular it's a dice, when it's many it's die. Right, that one is blue, and then do I have the green? The green, yes. So that is what we have. Okay, she takes the blue dice and divides it by the value of the green dice to generate the common ratio. Alright, so we've got a geometric series, and how do we get the common ratio? Is the value that we get on the blue dice, we divide it by the value of the green dice. And then we are told further that the number of the on the red dice will represent the first term of the series. This is A. This one is talking about R. Okay. Right. Now the question is, what is the probability that the sum to infinity converges at 10? Alright. This is certainly a higher grade question, guys. And it demands a lot than what meets the eye. Okay. So let's just go through the question systematically, and hopefully everything will be representative. Okay, alright. So basically, guys, we've got a geometric series, right? Now, the question is, what type of a geometric series when we talk of convergence? I kind of missed the idea, because the opening statement says a geometric series, meaning any geometric series, because the A part suggests any, right? Any geometric series. I kind of got fooled by the convergence. I got stuck onto thinking about the convergence irrespective of how the general opening statement was like. So these are some of the questions that truly highlight a few issues. But again, we can debate, because for me, if we're going to talk about a convergent geometric series, in my opinion, it sounds like it's a super restriction. One can think of it as such. Super restriction. So I would rather examiners perhaps try to learn the right way of examining, like those of the past. being as clear as possible as to what is expected, because being vague is really unacceptable, not in standard examinations. I do get the feeling that sometimes in real life, of course, we do get some vague issues that we need to respond to. But I think in a standard exam, it's only fair to make sure that the student fails the question due to their lack of ability to handle the question. But if we create such a situation where an ordinary matric student who does maths cannot understand the question fully, the question sort of throws ambiguity as this one, it's really, for me, not quite a good thing. But hey, what can we do, guys? We don't make the rules. But I do feel though they need to change in this regard. Exams have always been very clear on what is required of the student in each question. And when this is the case, sometimes you get to ask yourself, am I answering the question right or wrong? If you find yourself in that corner where it's a forked road and you've got to choose one, honestly speaking, I don't know. That is quite wrong. Okay, that's quite wrong. Anyway, guys, let's see. Geometric series such that A has how many possibilities? It can be 1, can be 2, can be 3, can be 4, can be 5, can be 6, because this is out of the red die. So literally we've got 6 possibilities here. Okay, so that's what we've got for the term 1. Now let's look at the common ratio. The common ratio in this sense is that this is a geometric series, so it doesn't seem to be necessarily the converging geometric series, although this is suggesting as much, which is where I got caught pants down. Right, so here we need to know how many common ratios are we possibly going to have here. Remember, 1 can divide each one of these numbers. It can divide itself, that number, that number, that number, that number, that number, right? So there's 6 possibilities for 1. 2 can divide that number, that number, that number, that number, that number, that number. As we can see, each one of these 6 options can divide all 6 possibilities. So this means we're going to have essentially 6 plus 6 plus 6 plus 6 plus 6 plus 6. Or essentially we can just say 6 times 6, which gives us 36 possibilities. Okay, so I'm doing it how Mr. Masonda did it, right? Right, because I think it makes more sense. And of course, this is more of the fundamental counting principle, isn't it? Yes, the number of ways we can express one idea and the other, then the total outcomes are going to be the product of those 2 ways in which we can do each individual. Yes. So that's the idea, guys. So essentially, the sequence goes on even for this, for that. That's why we end up with the 6 times 6, or you can just say 6 plus 6 plus 6 plus 6 plus 6 plus 6. It's going to be 36. Right, but now remember, for convergence, what do we need? R can be in this manner. It's going to be a proper fraction. For convergence, we know R must be less than 1, greater than 0. We're not going to have minus 1 here because this is a real life situation. So R must be a proper fraction between 1 and 0. So such that we're going to have 1, but it cannot divide itself, but the next number can be 1 over 3, can be 1 over 4, can be 1 over 5, can be 1 over 6. Oops, I forgot. We have exhausted it. Then the next one is going to be 2, but not over 2, but over the next one, 3, 2 over 4. We've got 2 over 5, 2 over 6. So this is a very tedious question. Hang on, okay? Can be 3 over 4. Can be 4 over, superb. 3 over 5. Can be 3 over 6. Can be 3, no, it's going to be 4 over 5, sorry. And 4 over 6. This is going to be 5 over 6, okay? Those are the possible common ratios that would link up to convergence. This is where I got caught, because I kind of focused on this, because it sounded, and perhaps is arguable, that one could consider the restriction on the common ratio to be purely on convergence rather than any other common ratio. But again, the question didn't come out clear about the restriction. So perhaps a student who chooses to narrow this to convergence may not necessarily be marked wrong. I suppose it should be accepted. But again, it depends on the discretion of the examiner. So how many are these now? So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Let's see. 1, 2, 3, 4. Okay, there's something missing here. We didn't do over 5. So 4 is 1 over 5. 1 over 6. Then 2 over 3. Then it's going to be 2 over 4. Then 2 over 5, and so forth. So let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So this is 15 possibilities. If at all one decides to restrict the common ratio to the one that essentially speaks to convergence. So now, folks, we know that the sum to infinity is going to be A over 1 minus R. So how do we deal with this? Now we need to decide which common ratio would work. Let's say we've got a half. Let's say we've got a half. The common ratio is a half, because it has to be the one that fits the category. So we will say, okay, we've got A over 1 minus a half. So this gives us A over 1 minus a half is a half. So this becomes A times 2 all over 1. So the question is, what can we multiply by 2 to get 10? It's 5. So this is 5 times 2, which would give us a 10. So this means the A value must be 5. Right. But now there's many other halves here. 2 over 4 is a half. 3 over 6 is a half. So there's 3 of those possibilities. So if the common ratio is any of those 3 and the A value is a 5, we win. Okay? Great stuff. So this one is going to force us, guys, to work through these one by one. Okay. The second one, what happens when it is a third? So we've got A over 1 minus 1 over 3. This is A over, this is going to be 3 minus 1 is going to be 2 over 3. Right? So this is going to be basically A times 3 all divided by 2. Now the question is there any number that we can multiply by 3 and divide by 2 and it gives us 10? 3 is not a multiple of 10, so it's not going to work. But we can check the biggest number to see. Let's say 6 by 3, that's 18, divided by 2, that's 9. So if the biggest number in this setup doesn't give us 10, so none of these are going to do it. So this one is out. So the third is cancelled. Right, so it goes away like that. So where else do we have a third? 2 over 6 is also a third, so we get to cancel some things. All right, let's keep moving. The next one, what about a quarter? So this is going to be giving us 3 over 4. So this becomes a times 4 all over 3. Now, is there any number that we can multiply by 4 and divide it by 3? Then will give us 10. Well, 4 is not even a factor of 10, so it doesn't look like it of these ones. But let's check. If we take the biggest, so 6 by 4, that's 24. 24 divided by 3 is 8. So this already says this one is not likely to work. Because if in the biggest a value doesn't work, so none of the others are going to work. Right. So again, we've got 1 minus. What about 1 over 5? This gives us a over, so this is going to be 4 over 5, okay? Right. So this means we've got a times 5 divided by 4. Well, is there any number of these ones that we can multiply by 5 and divide it by 4 that will get 10? Not really. But if we take the biggest number, 6, it's going to be 6 by 5, that's 30 divided by 4. That's going to be less than 10, isn't it? So 30 divided by 4 is basically 7.5, isn't it? Yes. So it won't work. So the fifth doesn't work, so it goes out. Unfortunately, guys, this is one of those questions where we're just going to have to go at it step by step. 1 over 6. What about the sixth? So this gives us a over, it's going to be 5 over 6. So this means we're going to have a times 6 all over 5. Again, if we choose the biggest number, 6 times 6, that's 36, right? If we divide that by 5, we get 7.2. So that means all the others are going to give us a small value. All right, so the sixth goes away. And then let's check 2/3. Now 2/3 is going to give us a over a third, right? Basically. So we've got a times 3, essentially. And there's no number that we can multiply by 3 and we get 10 of those whole numbers. So essentially, it's not going to work. Okay? Right. So that 2/3 goes away as well. Right, let's see. What about 2/5? What is that? So this is going to be a over, then we get here 3/5. So this means we're going to have a times 5 over 3. Right. So, again, is there any number we can multiply by 5 and divide it by 3? Yes, there is. 6. Because if we put a 6 in there, it's going to be 30 divided by 3 is 10. So if we put a 6 by 5 over 3, we get 10. So this one works. So 2/5 works hand in hand with the 6. Okay, so that one is good. And then what about the next one? Jump this one because it's a half, so 3/4. What about it? So we get a over, this is just going to be a quarter. We already saw that it didn't work, but let's go for it. This one is going to be a by 4, and there's no number here that we can multiply by 4 and get 10. So this one is not going to work. So 3/4, it's out. Okay, good. By the way, 4/6 is 2/3, isn't it? So that one should go as well, so that we don't waste time. Right, so that one doesn't work. What about 3/5? So this is going to be A over, this one gives us 2/5. This is going to be A times 5 all over 2. So obviously when we put a 2 there, so it's going to be 2 times 5. No, not 2 but 4. 4 will work, so it's going to be 4 times 5 divided by 2, that's 10. So we see that, okay, 3/5 works with 4. So that's it. Yeah, guys, it's a long question, unfortunately, and it's crazy on top of it all. Alright, so let's see, guys, we've gone nicely. So what about 4/5? So this is going to be A over, we see there that we get 1/5. This is going to be equal to essentially A times 5. What can we multiply by 5 to get 10? It's going to be 2 times 5, which is a 10. So this one works. So 4/5 works when it goes with the 2. Right. Okay, so let's keep moving. Next one is essentially 5/6. Oops, 5/6. This is going to be A over 1/6. This is going to be A by 6, so that one is not going to work. There's none of those numbers that we can multiply by 6 to get 10. So we have finally exhausted the possibilities of the common ratios that we can get that will actually work. So now, folks, we know that the probability, to answer the question, we can say then the probability of the event, okay, I don't know what is happening now, is going to be, first, we saw that a half can work, but it goes with a 5, isn't it? So we will say, well, it's either going to be the probability of having a 5 for the A value, and remember those two are independent events, to have a 5 and a common ratio that's a half. That can work. Or the probability of having, what worked again, it was 2/5. So 2/5 went with 6. So it could be a 6 and 2/5. Right? Or the probability of, if we look at it, it's going to be having a 4, right? And 3/5. Or the probability of having a 4, no, we're done with that, having a 2 and 4/5, or 4/5. Okay, so that's what we have over there. So those are the possibilities that will get us to where we want. Now remember, these are independent events, so it's going to be the probability of having a 5. It's just 1 out of 6 options for that portion here. Then we multiply because these are independent. Now what is the probability of having a half? It's 1, 2, 3. So this is 3 over, how many possibilities? We said in total they were 36. Remember, or is a plus. Now the probability of having a 6 is just 1 over 6 times. Having 2/5 is just 1 out of 36. Plus, having a 4 is just 1 out of 6. Times having 3/5 is just 1 out of 36. Plus, the probability of how many of these? 1, 2, 3, 4. 1, 2, 3, 4. So we've got the possibility as well here of having 1 out of 6 by 1 out of 36. So if we summarize this, guys, it's just going to be this one is just 1 over 6 times 3 over 36. Right, we can even simplify that if we want, plus there's 3 of these, so we're just going to say 3 times 1 over 6 times 1 over 36. Now let's sort out the answer quickly. So we have 1 over 6 times essentially 3 over 36, but one can say it's 1 over 12. Right, plus 3 into 1 over 6 times 1 over 36. So the answer that we get is 1 over 36, okay? Right, so that's the answer, guys, that you folks had to come up with. Obviously, the answer that I came up with when I made this super restriction of convergence, it came up to be 1 over 15. I think it's quite an answer to be considered if a student came up with it, since the question wasn't quite clear as to where exactly were we playing at. Otherwise, guys, you can see some questions can be complex, so a little bit of mental preparation and a full understanding of how things work can be necessary. And of course, these are questions to train a student on how to strategize. Most likely not going to happen in the exam, because a question that can take around 27 minutes to demystify fully, it's unreasonable to be in the final exams, right? Right. But again, you never know, hey? Some other questions may be too easy, so that a student can spare those last 40 minutes to perhaps dance with the shark like this. Otherwise, guys, this is it. I hope you enjoyed the video and that you learned and you can see what goes in where and how to get your stuff done. Otherwise, good luck for your upcoming exams. I'll see you again next time. Goodbye.